So the next speaker this morning is Sigrid Schmitz. She earned a PhD in biology, and since then she has conducted research and taught various courses on gender in STEM. She chaired, so she has been quite busy and she had very important roles in the last 20 years. She chaired the Competence Center for Gender in Natural and Computer Science at the University of Freiburg in the first decade of the century. She was then professor for gender at the University of Vienna. And she has recently completed the chairing of a project Gender in STEM Digital in Berlin. Today, she will talk about the necessary competencies for the debate, and I would ask required change about disciplinary images and culture in STEM's disciplines. So also the need for this change has been fully recognized, let's not exaggerate here, with a fully. It is very hard to break down the persistence of these images and basically of these gender stereotypes. So Sigrid, welcome, and the floor is yours.
Yes, thank you very much for inviting me to this conference. Can you hear me?
Yes, we can, very well.
Thank you very much. So thank you very much for inviting me, and excuse me, so I only can participate remotely. This is due for care facilities. And thank you, Francesca, for the kind introduction. I want to take you on a tour de force, knitting various perspectives together from gender dimensions in STEM. And this is how disciplinary images, the nerd, the Einstein, the empathic biologist, and disciplinary cultures, the habits, practices, and institutional structures produce and legitimate in and exclusions of women, further genders, non-whites, and even males from STEM disciplines. And thank you, Yolanda, for introducing the intersectional concept. By elaborating on disciplinary contrasts, we can also, and this is what I want to show, reveal a more differentiated knowledge for improving gender awareness and inclusion in STEM. I aim to unfold the underlying stereotypes that frame gender disciplinary images and cultures, but not only concerning individual beliefs, but also their embeddedness within social structures and symbolics. And these are the main three of gender and intersective dimensions. I will elaborate on the basic of such descriptions taken from brain research and show how the analysis of neurogenderings uncover methodological distortions and produce new knowledge about biosocial development of the brain and its entanglement within powerful social cultural contexts. And this is much for 30 minutes, but my opinion is that awareness and understanding of these mutual interrelations is important to provide actors for a cultural change in STEM. And only a cultural change will facilitate a sustainable equity in STEM concerning intersectional facets. And this is what I call literacy. So I just want to move further here, but it doesn't work. So this is what I call literacy. And I will touch during the talk some features of our open access portal, Gender and STEM Digital, we developed at the HU Berlin in the last years to provide students, teachers, and gender equity actors with content under Creative Commons and e-tools for discussion of and awareness of these facets. Women aren't failing at science. Science is failing at women was the title of a blog post 2020 in Nature. It commented on the fact that women are at least as or even more productive than men in scientific output without obtaining the relevant leading positions in STEM institutions and without being adequately acknowledged as first authors in leading journals. So we have to uncover the hidden prejudices, assuming that women would lack intellectual capacities or preferences for scientific work in STEM in order to dissociate these apparently objective and neutral appreciations of scientific qualification from a seemingly naturalized binary determinism. And this is to foster transfer knowledge between gender and STEM research and gender equity issues to achieve such a change of cultures. And I just want quickly to point to some analysis from referring to physics, some examples of images and cultures. Martina Erlemann, for instance, demonstrated the knitting of masculinity and physics through media analysis. Male researchers are most often shown in close contact with the observation instruments or the laboratory equipment. Research practices in physics are often linked to metaphors of battle, war, or exploration, all male assignments. To the figure of the father creator, the lone genius, objectivity and rationality of science research is assigned as a competence better mastered by men. Images of women are rare, and if so, they are depicted as exceptions or shown in communicative contexts, for example, when imparting the knowledge of their discipline to society. And Helena Patterson found out through her laboratory research in an American plasma physics institution, such masculinization strongly associated with the machines to be constructed and administered by men. Boys, men's interest for machines, power, electricity. Powerful machines, big, high power toys, a classical male thing. This is a quote from an interview. Dirt, sweat, danger, noise. Another quote is an environment unfriendly to women. And there was the analysis of Katrin Haase and Stine Trent-Möller, who showed a typology of cultures, of research cultures in physics, from Hercules culture to caretakers and working men's. The point is, and Sharon Trawick already revealed this in 1988, that not only physics, but technically loaded disciplines, computer science or engineering, cover these facets. They present and perceive themselves as, quote Trawick, the culture of no culture, neutral and objective. And with this, they also ignore that and how these cultures produce their effects within their own disciplines. Those hidden prejudices shape rules and norms. For example, the relatedness of a masculinized image with rationality and competition in center of the disciplines is less compatible with conceptions of femininity. And many studies revealed how related routines and habits construct obstacles for career, funding, or acknowledgement via publications for women in technology, engineering, computer science, and physics. And I just refer here to a great statement of Lia Lang. I think the Genera people know her. She's a physicist and gender studies scholar and works at the DESI, and gave for our portal a short statement on these cultures and makes clear how the equation of a competent physicist with force and rationality makes it harder for women to conform to that image. Not least, it leads to men preferring men when it comes to fill postdoc positions or allocate funding. And this is not always conscious. And these machines of thinking and communication and collective practices hinder women and also men, for example, with family care duties, in getting fully included in the discipline. And all these cultures are grounded and affect the validation of belonging and suitability within the discipline. And it burdens a heavy load of gender identity work on all those who do not fit into the equivalent image. And I would like to show this in contrasting physics to biology, because you have to be cautious in generalizing disciplinary images and cultures across them. Biology has a high percentage of incoming female students, up to 60%. This may be due to the image of the biology as smart science, the tenacious and uncomplaining working to research animals and plants with empathy and intuition. All practices and skills which are related to a seemingly natural, nature-bound femininity. It's also racialized, by the way. And Sarah Jane Lassie and co-workers showed impressively that assumptions of the necessary field-specific brilliance predicts the number of female PhDs in STEM disciplines, with a higher assumption of needed brilliance in technical, engineering, or physics, related to a lower number of PhDs in those fields on the one side, and simultaneously a devaluation of female brilliance in line with the smart discipline biology. So shortly, biologists do not need such brilliance because their discipline is not so brilliant. And that speaks, although there are a lot of female role models in biology, for a retainment problem because the glass ceiling remains. There are in Germany since years now not more than 90% female professors in biology. And can show on the interface in bioinformatics between biology and computer science that we find similar differentiations. But there are also differences in subfields of biology. More masculinized images in technique-oriented laboratories as genetics or neurobiology, more feminized images in nature-bounded field science. But in field science, in barren areas, in the wild, scientists' images suit with the masculinized power of resistance, bearing an invisibility paradox. For women who cover their femininity with masculinized dressing and modes of communication for the price of visibility, which they then have to regain painfully for their further career. The back part of visibility is tokenism, the one female, the one black, the one homo, who should represent the whole of a minorized group in the discipline. And I strongly recommend here the documentary Picture Scientists from 2021, because referring to three biologists, three women from biology, chemistry, and geology, smart sciences, the main point is here that it does not only show sexual harassment, but it relates these individual experiences and strategies to the numbers of discrimination, mostly invisible under the waterline of the iceberg. So what can we learn from these disciplinary contrasts? A little bit similar to the Leslie study, Cherian et al. Showed that in computer science, engineering, or physics, assumptions of masculinized and technicized capabilities relate to lower rates of inclusion, also concerning publications. Whereas in smart disciplines, that's chemistry or biology, also partly in math, recruitment of women is higher, as I have already shown, but retainment is a problem. Interestingly, the first debates about publication biases in editorial boards appeared in the bioecological fields. And a very recent study showed that in those fields of behavior analytic journals, which are more feminine, there is a rising of female authorship, but a diminishing in the last years again of recommended positions in first or last authorship. So, and we have a lot of studies which I will not refer here to in detail how the effects of these images are concerning funding, publication record, hiring, salary, and so on. And I took Thomas Bragg's great, for physics grade slide on some of these outputs. What has been shown is that women are less capable to conduct high-quality research, even if they possess equivalent degrees and qualification. So we have to look behind these sex, gender descriptions. And it has already mentioned top-down directives and governance of science is important. And I refer to one paper of the League of European Research Universities in the same vein as Londa did. And what I find important is here the connection of fixing the numbers, the three objectives, and their connection of fixing the numbers, so the durable rise in numbers of women in STEM, based on in-depth knowledge about gender aspects, fixing the knowledge. Londa has talked about this. And the impairment of such knowledge to all actors in STEM, fixing the competence. And I think this is important. But why I took this example is because of two quotes, which are not mentioned so often in relating to EU or other initiatives. The first is interaction often occurs between sex and gender relevant factors, and it can be hard to distinguish between the two. So in other words, the analysis of sex/gender, as we call it, and the interaction between biological and social cultural factors can be challenging, and it needs input from both STEM and gender research to do this. And I would like to discuss, but this is not here the case, but perhaps later on, how these calls for researching sex, gender, or sex, and taking the more popularized version of the NIH, London already quoted, to research sex down to the level of every cell, how this bears the danger again to re-essentialize male-female differences. And we have to discuss this, I think, and I would like to discuss it. Sarah Richardson from the Harvard Gender Science Lab just this year published a paper in dealing with this danger and discussing the concept of sex context. A second quote, important for me, is the risk of exaggerating existing small differences or of wrongly claiming difference can result in perpetuating stereotypical views and or in unjustifiable treating of men and women differently. In other words, biased statements of differences must be replaced by approaches to study diversity, the attenuation of numerous influencing factors, and the reflection of social impacts as part of all research. So, and with this, I come to brain research. I will drop this and go to the first main point, which is always related to. So you can try to find out now which of the figures A, B, C is the same as the figure on the left side. This is a prominent task for mental rotation. And mental rotation is mostly argued to be a crucial factor for enrollment in STEM, in math, physics, or chemistry, for example. But the highest gender differences favoring boys or men has been shown in mental rotation, but it has also shown that the assignment that such a task, which I presented there is a spatial one, produces the difference. And if the task is, for example, presented as a task of perceptual capability, the gender differences diminish or vanish. The fear that one will confirm a negative stereotype about the group the person belongs to diminishes their own performance. And this is the stereotype threat. There has been much work on it, also concerning math tasks, also concerning intersectional discriminized group belongings. And it has been shown that brain activity changes with the stereotype threat, especially according to areas of attention and emotional load. So it seems that the time needed to suppress the negative stereotype is reflected in the brain and results in more time being needed to solve the problem. Cordelia Fine has written a whole book. It's also important to be a little bit cautious about this argument of mental rotation and STEM enrollment, which is, by the way, often also taken by gender equity discourse. Carla Sanchez-Segura and her group showed how the self-schemata is more important than the capability or the process per se, and the stereotype threat, for example, does not occur in STEM students, but only in non-STEM disciplines. So it is the self-schema more than the capability per se, which counts. So just to give you a short, I think I have 11 minutes, okay. A short, some examples of brain research. I take the language example often because it's one of the examples where female outperform males in the stereotype view. And what you find are contradictory results. On the left side, you see the main study of Schmitz, one of the first brain imaging studies showing females are processing language with both brain areas bilaterally in male, only with one on the left side. What you see in the image on the right is in the brain on the left side. This is neurobiological convention. But there was only 19 male and female, although the study is cited in nearly every review of language and gender. Julie Frost and others, referring to Schmitz and wanting to prove the study with more participants, 100 participants, 50 men and 50 women, showed, with this 100 participants, there were no overall sex differences detectable in a word pair association. All in average, participants processed mostly the language task on the left side. There is, I can try to show you here, I don't know if you see it, one little activation on the right side, but this is the cerebellum, which is important to touch a little mouse because you're lying in the scanner doing this. You cannot do very much, else you have the researcher gets no image. You can only click with the left hand on the mouse, so the right cerebellum is activated. The other fields here in a presentation, and this is a little bit a uncommon presentation with the average of 50 men versus 50 women. The areas of language processing, Broca, Wernicke, as we know, are mostly left side activated. And they also did a presentation with the participants randomly assigned into two groups to show these differences. So just shortly, there are other contradictory results, for example, concerning spatial cognition. One study from Rhön, much cited, 12 men and 12 women trying to find a way through a virtual maze while lying in the scanner, and they assessed women with a more frontal and parietal lobe activation referring to landmarks, and men more with hippocampal activation referring to directional analysis. But there is another study referring to Rhön doing this with a map of Maastricht, which found no differences. So just to make it short, for every study, you present me a difference, and I bet I never lost this bet since the last 20 years. I find a study which shows contradictory results. So what feminist neuroscience did in the last decades is to show how these contradictory results are related to methodological variations. For example, how many participants are taken in the Schmitz study I referred to. From the 19 females, on average, bilaterally processing, only 11 did it in real. 8 processed laterally. These analyses from the last 20, 30, 40 years speak against simplified generalizations over sex categories. The heterogeneity within gender groups most often is stronger than sex homogeneity. And even though there are very contradictory results, popular scientific publications predominantly cite studies that difference between women and men. This is the publication bias, which also holds for scientific reference. And more, these methodological reflective analyses have found their way into also high-ranked neuro journals. One point is that these wonderful, colorful images you see are produced. It's important, brain imaging is important, that's not a question, but what is processed, data analyzed is a decision. And I would love to show you another video from our portal where Annelies Kaiser, one of the most important researchers in the field, explains that. You can look it up. But what she showed, and we published this in 2009 in Brain Research Reviews, is that within the scope of the community, you can take different statistical measures to get the difference or non-difference out of the groups, the group comparing. If you take one statistical measures here from comparing 22 men and 22 women, you find no difference between the two groups of women and men. And in the other case, with another statistical analytical tool, also within the community scope, you find differences. So this is not always consciously done, but it is part of knowledge production. So this is the one point of neurogenerics. The other point is that since 10 years now, the Neurogenerics Network, this is an expert network, international transdisciplinary of neurosciences, medicine, philosophy, social, cultural studies, gender and feminist science studies, works closely together and do not only evaluate the current state of research on gender and intersectional distortions, but even more develops detailed and enriched approaches of neuroscientific analysis to take into focus the entanglement of the biological, the social, and of diversity, instead of simply binary sex or racist concepts. And I will shortly refer to these four terms, which are the leading terms of the network: overlap, mosaicism, entanglement, and contingency. So if you take two groups, females and males, for example, in cognitive skills, you can group the skills, you have two graphs, and there may be a statistical difference between the average, but there also may be some female and some male participants who are very polarized in their activity or in their capacity or performance, which make the difference, whereas the others are very heterogeneous. This you cannot see with the significant measure, but with the effect size. So the effect size, or the Cohen's d in this case, shows how homogeneous or heterogeneous the groups are. It's between 0 and 1. The higher it is, the higher is the homogeneity. So if you look at math performance, there is a very low effect size, meaning that the groups are overlapping in case of heterogeneity. In spatial orientation, it's a bit higher. Mental rotation, it's higher. Also in brain measures, you can show, and I've shown this example of laterality in language processing areas, it's a low Cohen's d, showing that 85% or so are overlapping. And this also holds for the fiber that connects the brain hemispheres, the corpus callosum. But overlap is not sameness. It refers to heterogeneity. And this has been shown in the last years from, for example, the group of Lisa Elliott for the hippocampal structures. You remember the spatial orientation, which is very heterogenic in a meta-analysis comparing male and female brains. And it is also the case within one brain, within my brain. Daphna Joel and her team from Tel Aviv University, together with MPI in Leipzig and Zurich, they researched 1,400 brains. And in those brains, they researched 116 brain areas, which are referred to in literature as being female or male oriented from the structure. And what they found is that how I speak personally, in my brain, I have areas which are more female orientated, those which are more male structured, and some which are in between. There is no female or male brain. The variability within the brain is high, between 48 to 67%, and the consistency is low.
Sigrid?
Yeah, I know. I have 1 minute.
Okay. No, yes, we are really reaching the end of your...
I see the clock.
Yes.
I see the clock.
All right, very
So
good.
the other point is brain plasticity, and I only make this short. Our brain changes through our life. How we learn languages changes our language area. How we learn spatial orientation changes our structure. When we juggle with both hands, our motoric areas change, and also gendered experiences change performance and change the brain. So brain plasticity gives an approach how to research sex/gender, the not separable network of embodiment in the brain. I do this very shortly. We can discuss this. Also, social structures change the brain. This is an example of math test performance, which differs according to the structures of gender inequity in societies, according to gender pay gap and others. So this is what the Neurogenderance Network tries to analyze, to get into analysis, and the approaches and guidelines we try to develop. And with this, I come to the end. Sorry, I'm here a minute longer. All these phases have to be taken into account to develop strategies for change of cultures. For Walton, I refer here to says that the 20% share of women holding professorships will not rise as long as the unconscious gender assignments do not change. And this is, I think, what we have to do, not only implanting top-down strategies, but also fostering dialogue between gender research and STEM and building up competences for this dialogue. And I will not explain this further, but with our portal, we have sampled units, open access, Creative Commons, and some of them, and you can see it here, it was in Germany developed from the German funding on an organization which wants to have it in German, but some of the materials are translated or subtitled. I would like to do this further, and if someone is interested, Mary Lou, perhaps we can talk about this. I would like to develop it further. Here you find, if you go to this internet link, you can find it or under the gender in Mint Digital. You find it on the net. Thank you.
Thank you so much, Sigrid.
Sorry for being a bit long.